everyone. I'm so glad so many people are interested in Rails HTML5 sanitization. It's fantastic. Just a quick introduction for myself. I'm a director of engineering at Shopify. I maintain the Rails Sanitizer stack. And I'm also on the Rails security team as like the junior member. I wanted to start this talk by posing a security puzzle, a problem, a hypothetical. I want to talk a little bit about the software behind that puzzle to help you understand why it's important, also why it's dangerous if we can solve the puzzle, and then talk a little bit about how we're evolving Rails to protect you and your users. So let's start with the puzzle. The scenario here is, imagine you're running a website that's like a wiki or something that publishes a lot of user-controlled data. If there's a bad guy who wants to try to inject some JavaScript or something, you've got a sanitizer running, which makes sure that safe and valid HTML4 comes out and is rendered in your user's browser. Now, the interesting bit is that most browsers today are HTML5 compliant. And so the question is this: can you craft a payload that will pass through an HTML4 sanitizer, and when it's rendered in an HTML5 browser, is a security vulnerability? So a couple of phrases that we should probably define: sanitizer, security vulnerability. I want to get specific with these. So let's talk about an HTML sanitizer first. Wikipedia, helpfully, defines a sanitizer as something that takes one HTML document, produces a second HTML document that only has the tags and attributes that you think are safe. So it's like a policeman. Concrete example, if someone makes a blog post comment that looks like this, it's plain text, it's perfectly fine, it's perfectly safe. If there's some formatting in it, it's probably fine, let it through. If they want to do some weird styling, like a background red, that's weird, but you should let it through because it's not unsafe. But this is where it crosses a line. There's a script tag where they're trying to redirect your user's browser to an evil site. So we want to block this. And what a sanitizer will do is it'll see that markup, and it'll do something like escape the tags, so they're no longer unsafe. Or it will remove that part of the document entirely. Or the Rails HTML sanitizer specifically will remove the tags and leave the content, which is a perfectly fine choice. The Rails HTML sanitizer stack has looked the same for the last 10 years or so, and this is it. At the top, we have all the Rails gems, which use the sanitizer gem, which uses Loofah for some sanitizer primitives, which uses Nokogiri and libxml2 to make sure that we're parsing all the markup correctly. And that's actually a really important part of the stack. Most attacks take the form of payloads that are intended to confuse buggy parsers. So OWASP has this great cheat sheet where you can look and find like a historical archive of real-world attacks. And people use this for testing purposes. But the thing is that they do things like adding 3 quotes to maybe trick your filter into believing it's still in a string. Having libxml2 at the base of the Rails sanitizer stack means that we're always going to parse that correctly, and we're always going to have a well-formed tree. So here you can see a tree where we've got an image tag and a script tag, and a sanitizer will look at that, will see the script tag, and if you pass this through Loofah, Loofah will just remove those tags, and you're left with whatever's left over, which is an empty image tag. And this is what you want your sanitizer to do. So in summary, it stops bad actors, and it does this by first parsing correctly, and then removing unsafe tags and attributes. That's it. That's all a sanitizer is. So I'll check the box on what is a sanitizer. A couple of other words in here we should probably define and be careful about: HTML4 and HTML5. So let's spend a few minutes talking about HTML standards, and I promise it'll be interesting, and hopefully you won't fall asleep. HTML 4.01 was announced in December of '99, and that's pretty much when evolution stopped on HTML4. If you want to get a sense for what this spec looks like, if you go down and you take a look at the grammar, how the HTML syntax is defined, they have like grammar. And this is fine for whatever it is, but it's missing something that's very important, which is there's no guidance for error correction, right? They're defining a grammar like Bacchus nor form, and it doesn't tell you how to correct markup. And I don't know if you're aware of this, but there's a lot of broken markup on the internet. So what I mean by error correction is you can have HTML come in that's malformed. You have an open B tag and open I tag, and then they're closed in the reversed order. what should a parser do? The spec gives no guidance. So even within Nokogiri, depending on whether you're running on CRuby or JRuby, you'll get two different results. CRuby will orphan the 3 at the end of the string, but Nico HTML will wrap that last 3 in an additional italics tag. Which of these is right? They're both right. It doesn't matter. The spec doesn't say. Everybody's going to fix broken HTML differently. And this actually means that every HTML parser, HTML4 parser, is slightly different and unpredictable, and that's bad. And in the Nokogiri README, we actually say, we're not going to fix these behavioral differences. Like, you get what you get. That's it. Thankfully, the world has moved on from HTML4. And now there is HTML5, which is also called the living standard. If you actually click through and look at the introduction for this document, they actually call HTML5 a buzzword and insist on being called the living standard. Just a little bit of spice from this document. I have a secret to share with you all. Come closer. Come closer. Come closer. The HTML5 spec is a goddamn delight. This document is so amazing, and I'm going to tell you why. Number one, it's got pseudocode in it. If you go through and look at how the HTML syntax is defined, which I will now do for you, it's got all these modes defined. And this is actually a specification of a state machine. And if you click through into one of these, it'll actually tell you, like, oh, if you see this tag go into that state, if you see this tag go into that state. And what this means is that every HTML5 parser is just translating the pseudocode into real code, and that means that they're all very robust, and they all act the same. And that's fantastic. The spec has sparkle and wit. If you've ever seen the closing sarcasm tag from somebody on the internets, the spec actually talks about this, and it says, take a deep breath, and then act as described by any other end tag. All right, so it's not laugh out loud funny, but for a technical spec, it's pretty good, right? Okay, another one, instructions on how to read the specification. Read it cover to cover multiple times, then read it backwards. Then read it in random order and check all the cross-references. Like, again, it's nerd humor, but it's pretty good. There's a human behind this spec, and that's what I appreciate. You can actually see the humanity come through. It's got a little bit of history, too. This spec has a whole section about the history of the what working group and how they, like, essentially, there's the schism with the W3C. So W3C are framed as idealists who wanted the world to write XML and everything to be perfectly well-formed all the time. And the browser implementers were like, well, incremental changes and improvements is the way, and you need to be backwards compatible. And so they essentially split with the W3C and formed the what working group. And they formed it according to some guiding principles, which are also in this doc. And these are good guiding principles, bear with me. Technologies need to be backwards compatible. If you're a browser maintainer, that makes sense. The specs and implementations need to match, even if this means changing the spec rather than the browser. So think about this one, right? If your browser is not working like the spec, if all the browsers agree, the spec is what's wrong, and you file a bug report against the spec. And that's actually how it works. And lastly, the specs need to be detailed enough that implementations are interoperable and don't have to reverse engineer. Basically, all the parsers are going to act the same and be predictable, and that's wonderful too. It's got error correction instructions, so even if the markup is bad, they'll still behave the same. All of this is standardized. It's a lovely document. It's actively under development every day. It has a test suite that we get to use in Nokogiri. I could keep going on, but like, I've only got 20 minutes. So let's go back to the puzzle. We've talked about HTML standards. I've given you a little bit of exposition. Let's talk about why this is a dangerous question. And I'm sure you've put it all together already. Rails has been using an HTML4 sanitizer for 10 years. And browsers are all HTML5 these days. Right? If we can find a solution to this question, if we can actually craft a payload that will be a security vulnerability in HTML5, this means that everybody's Rails site is vulnerable today. Bad news. There is an exploit for this. So you can see this HTML is a select tag with a style child, and a script tag. And when you parse this with HTML4, it goes through and comes back at round trips. It's perfectly valid HTML4. But when you parse it with, when you look at the tree that gets generated, you see some interesting things. You see that there is a select tag and a style tag, but the style tag contains string data. It's character data. It's a string constant. So that script isn't actually a tag. It's text that belongs to the style tag. And that might seem weird and dangerous, but that's how the HTML4 spec works. Unfortunately, there's no script tag for the sanitizer to remove. It sees the select and style tags, and it sees a string. And so this goes through. If you run this through Rails Sanitizer, you will get the script tag back out on the other side. You have to remember that that is character data because it's in a style tag. What happens when you run this through an HTML5 parser, though? This tree is different. You have a select tag, but there's no style tag, and the script showed up. Like, this is going to run JavaScript in a browser. That's bad news. So what's actually going on here, I could walk you through the state machine of the browser, of the parser. That's kind of boring. In summary, HTML5 says a style tag can't be a child of select. So when it sees the style tag, it removes it, and whatever's left over is parsed as normal PC data. It's parsed as part of the document, and you get a script tag hanging out, and it's a vulnerability. So how did we try to fix this? So bugs like this were being reported as early as like 2015. We've tried to fix them a number of ways. One way we try to do it is recursively sanitize that C data. So if it's C data in a style tag, you open it up and you sanitize it as if it were PC data, HTML content. And so those script tags would be escaped. And you could do that recursively as many times as you needed. Recursion is slow. And it also ruined a lot of C data. Like, it would just be entities hanging out where you expected to see a less than character. You'd see the LT entity. We tried prohibiting both style and select being together in an allow list in the sanitizer. And this kind of worked. It's kind of not a great solution because it's addressing the symptoms. That these two tags happen to not work well together. There might be other tags that don't work well together. And then lastly, we decided just for speed to just CGI escape everything that's in the C data. Okay, none of these were great because they ended up breaking people's HTML in subtle ways. And they also didn't address the root problem because there are two other exploits that are known. One is with an SVG tag, and one is with a math tag. Otherwise, they're all very similar. They contain style, and the style contains some other markup. So SVG and math are foreign contexts in HTML, and what this basically means is they are a Swiss Army knife for breaking parsers and sanitizers. This is a hilarious quote. Really what this means is that the rules for parsing change when you hit a math tag or an SVG tag, because SVG has a whole other set of rules for how those are formatted, and so does MathML. And so as a result, HTML4 doesn't know this, so it just parses it straight ahead. It'll give you a syntax error saying, I don't know what a math tag is, but it leaves it in. And you get a style tag containing C data. That's kind of what we expected at this point. But when you pass this through an HTML5 parser, this tree is completely different. You get a math tag that contains an empty style tag, and then your image tag has actually been promoted to be a peer, a sibling of the math tag. And again, this is going to immediately run that on error callback, and it's a vulnerability. So this class of vulnerabilities actually has a name that I learned while I was putting this talk together. It's called the Mutation XSS. That's a cross-site scripting vulnerability that comes about as a result of changing the tree. That's where the mutation comes in. And the funny thing is that all the parsers are doing the right thing. They're all following the specs. It's only the mismatch between the HTML4 and 5 specs that allow for the tree to get changed and the vulnerability to appear. I have all kinds of feelings about this, but the real solution long-term is to get the whole Rails stack to also use HTML5. So we have HTML5 parsers on both the client and the server, and this whole class of problem goes away. If you want to know like a lot more detail, there is actually a decision document I wrote on the Loofah project that was the basis for this talk. You can read a lot more there. Which brings us to evolution. So this is the sanitizer stack again. There are at least 5 libraries here. Maybe more if you count the Rails gems separately. And that felt really overwhelming to me to look at that stack and say, how do I get it all to talk HTML5? So I wanted to do a side excursion about how I deal with problems that feel overwhelming. What I like to do is I do outside in. I start at, or in this case, the top of the stack. I start at the top and I try to imagine, what does the solution look like on this level? I write a shim, and then I push the stack and I go down to the next level. And that helps me explore what the solution space might look like. So in this case, on the top level, ActionView has an accessor for a vendor that plugs in what you want your sanitizer callbacks to do. I can just set that to Rails HTML5 sanitizer, which doesn't exist yet, but that's the trick. It doesn't exist yet. So then I push the stack, and I go to Rails HTML sanitizer, and I go, what might this class look like? And I try to sketch that out. And of course, I am going to reference more things that don't exist, in this case, like a full sanitizer. So what does that look like? I can sketch that out and realize that I need to call Loofah HTML5 fragment, which also doesn't exist. So I push the stack one more time. Now I'm in Loofah, and I go, okay, well, Loofah inherits from, or subclasses, Nokogiri documents. Now I need to go into Nokogiri. So in this way, I can go down the whole stack. When I get to the bottom and I actually have real work to do, like when I'm in Nokogiri, I don't have HTML5, I got to do real work. That's when you start to implement in the other direction. So you go from the leaf nodes back up. This helps me manage the complexity. So you explore from goals to the prerequisites, and then you execute in the inverse order. There's a name for this, which is the Mikado method. And there's a book about it if you're interested. The short version is they tell you to draw a graph to track all of your dependencies and your work. And I do this. So this is a graph I drew for a libxml2 update to Nokogiri. These are all the problems and the things I tried to solve those problems. This helps me stay organized, and it also serves as a neat record of what you did, so you can pull it out in a talk when you need to. How do you eat an elephant one bite at a time? It's about taking small steps and progressing and not missing any steps. So this helps me. Hopefully, maybe it helps you someday. End of excursion. Let's look at our stack. Let's start at the bottom and work our way back up. How do we add Nokogiri support for HTML5? This took about a year from end to end. It would have been really nice if libxml just supported HTML5 out of the box, but it doesn't, and it never will. And here's an issue that says it probably never will by the maintainer of libxml. So I opened up an RFC to start a conversation about what are the alternatives? How can we actually parse HTML5 in Ruby? And we had a really great conversation, and we narrowed it down as a group to about 5-ish options. Validator.nu is a Java library, but it generates C++ code, so it might be usable in both JRuby and CRuby. Gecko and Blink, I'm sure you know. Libgumbo is an orphaned Google 20% time project, but it was wrapped by NogGumbo, which is a fantastic library by Sam Ruby, and Gammo, which is a new pure Ruby solution that was kind of untested. Nobody really knew much about it. We took a really hard look at NogGumbo, though, because NogGumbo already had the API we wanted. It's interesting to talk for a moment about how NogGumbo works. So libgumbo is a C library, and it generates a tree structure, the same way that you would expect any document is going to be a tree structure. And what NogGumbo does is it then traverses that tree structure and builds a parallel libxml tree structure, and then throws away the libgumbo tree. So it's got a little bit of an inefficiency in there, but we're able to use libgumbo out of the box to build a Nokogiri compatible document that then the whole Nokogiri ecosystem can use, and we can do XPath queries, for example. So really useful. It was decided. We all decided we're going to merge these gems. And one of the reasons we were going to merge them was so that we could pre-compile NogGumbo as well, because by this time Nokogiri had been pre-compiled. So I opened up an epic to track all of the work that had to go into merging the gems, both technical and human. And I wanted to talk about the human factors for a minute. I wanted to make sure the NogGumbo authors felt welcomed and didn't feel like they were losing a thing by merging their gem into Nokogiri. So I preserved Git history, so they had all of their commits rolled up to Nokogiri numbers. I sent them some Nokogiri merch. I have like a messenger bag with a Nokogiri character on it. And having them on the team has really made light work of all the support issues that we've had, which has been great. Steve Chaway. I want to give a shout out to Steve and give him a very warm thank you, because he's the one who's been maintaining libgumbo for the last 5 or 6 years. He and Craig Barnes, who works on LuaGumbo, are responsible for keeping this library up to date. So if I could ask everybody to give a little bit of applause for Steve. I hope Steve watches this video and sees everybody clapping, because he's not really part of the Ruby community, but he's just been so great to work with. Some low-risk work around licensing and pre-compiling and shutting down NogGumbo had to happen. We renamed things, right? Nokogiri HTML4 now exists, even though it didn't before, because HTML was ambiguous. There's a little bit of an open question about what should HTML point at going forward, which I'm not going to get into, but just suffice to say, libgumbo only has a DOM parser, and libxml has like a sax parser and a reader and a pull parser and a push parser and all these things. So to be done later. One interesting piece of functionality that broke was namespaces. So going back to foreign contexts for a second, SVG and math, if you recall, are special in HTML5. And they're special in that they have a namespace. So if you look at this on the far right, you can see that there is a namespace with a prefix of SVG. That's new. HTML never had namespaces before HTML5. And what this means is that if I parse, say, an SVG fragment, and I want to find the rectangle, I can't just do a CSS search on rect. I have to do this messy crap with passing in a namespace, which is super, super ugly and not a great user experience. And I wanted to fix this. Side note, Nokogiri compiles CSS queries into XPath. Like, here's an example of it doing this. So I'm going to talk about XPath going forward, but really this is about CSS query functionality, but it's implemented in XPath. So the first thing I tried to make sure that we could resolve that rectangle without providing the namespace was to just check the local name, right? There's a built-in function in XPath that just returns you the name of the thing without the namespace. So we can check that, and it worked, but it was 10 times slower than just doing a normal CSS lookup. That's really bad. No can do. So the next thing I tried is building a custom XPath function. So you can plug in your own C functions to XPath. And this one is just called local name is. It's a Boolean. It doesn't do so much string manipulation. And that was actually faster, but it's still 6 times slower than the original. This was no good. So I started thinking, why can't we have wildcard namespaces? XPath 2 supports this, but libxml does not. How hard would it be to patch the libxml that's in Nokogiri? Not too hard. I actually did it in about 30 lines of code. The version of libxml shipped with Nokogiri has this patch, so you can do wildcard namespace searches, and it's just as fast as doing a regular one, so ship it. But here's the interesting side thing that you probably don't know. There are now 3 different ways to do a CSS search in Nokogiri. You use local name if you are in JRuby. You use the built-in local name is if you're on a libxml system library, and you use the wildcard namespace if you're on a packaged vendored version of libxml. And each of them gets faster as you go. So that's a reason that you should use the packaged version of libxml if you have the option, because we're doing things like this to try to make it faster and more functional. The last thing I'll mention is we had to rewrite the document serialization in C. It's about 10 times faster, even with widget turned on. I recommend you always benchmark before you embark on a C rewrite, but in this case, it was definitely worth our time. Other things I could do in the future to improve memory performance a little bit more that I'm not going to talk about because I'm running low on time. We got this version of Nokogiri out, fantastic. In retrospect, JRuby still doesn't support HTML5. I would ask this room for help doing that, but I've given up hope on anyone in the JRuby community fixing this problem for me. So I feel kind of meh about being the maintainer of libgumbo now. That's interesting. But I will note that Ruby now has better HTML5 support than other languages. If you look at Python, they have like a pure Python version that isn't as fast, and they have a version that uses like a system libgumbo that's several years out of date and has security vulnerabilities. So we're in a pretty good situation, I think. All right, let's pop the stack. We'll update the lower level. We'll pop the stack up to Loofah. Loofah update took about 6 months. The code was actually not that hard. So Loofah, if you recall, inherits from Nokogiri HTML document. So first thing you do is we'll rename it to HTML4. Excellent. We'll make a new one that's HTML5. Excellent. We do the same thing for document fragments. We do the same thing for the helper methods. Like, boom, we expose everything, and then we let Rails HTML Sanitizer figure out which one it wants to use to defer that decision. So why did it take 6 months? Here's why. The tests were a nightmare. So all of these tests that we had in Loofah were from legacy libraries that I had like lifted their test suites, and they were all very dependent on like HTML4 parser peculiarities. And as we know now, HTML5 parsers are very different. And so I had to go through by hand and update all of these tests and eyeball them and make sure that they weren't accidentally doing something insecure. But after about 6 months, it was fine. Got it across the finish line. Great, let's pop the stack one more time. Rails HTML Sanitizer. And this is where the work really started to speed up. Ketbeck has a line that he uses, which I love. When you have a hard change to make, first do the work to make the hard change easy, and then make the easy change. And I definitely channeled that advice here. So a bunch of commits that I did that simply cleaned up the code. So I added back covered, I added back coverage in tests. I did a prefactor, I did another prefactor, I refactored into composable concerns. Like, I'm actually proud, this is like computer science that I'm actually doing here. It felt really good. I renamed some things, I reorganized the tests, and then this was the change that actually introduced HTML5 support. Like, it's glorious, and I'm so proud of this. I couldn't be happier, which is why I'm showing you all this code right now. Yeah, thank you. Thank you. So we shipped Rails HTML Sanitizer in May of this year, and then all that we had left was the Rails integration. And really, I was trying just not to screw it up at this point. Just wire up the pieces that we have, make sure that it doesn't break people's apps. So going back to action view helpers, right? There already was like a pluggable approach here where I could just plug in a vendor. There was only ever one vendor, and it was Rails HTML Sanitizers. But like, we could hypothetically plug in other ones. Like, it could be as easy as writing a vendor like this that simply calls out to the HTML5 sanitizers and then update what it should be. But we can't actually do this because JRuby doesn't support HTML5, and because we don't want apps to break. And there are going to be apps whose tests depend on HTML4 behavior, and we want to give people a chance to upgrade. So we got to introduce some application configs. The first one is for Action View Sanitizer vendor. New apps default to HTML5. Old ones will need to upgrade. But it should, unless you're doing something in your tests that's very specific, this should be a seamless upgrade. And then the resulting change was just this. We introduced a new helper method called best supported vendor, and best supported vendor does what you think it does. If you support HTML5 on your platform, it'll use it. And we just repeat that for the other parts of Rails. We did it for action text, literally the same thing. We had to do some work to plug in the vendor, but that was it. And then this one is particularly interesting. So there's a couple of gems that do testing behavior. So there's action dispatch assertions and Rails DOM testing. And both of them make assumptions that they're going to parse an HTML4 document. So what I did was I added a new application config in Rails that those gems can inspect and change their behavior. So by switching this, you're going to update Rails DOM testing and action dispatch assertions, and all of your view tests will just do the right thing, which I think is pretty good. So this is the whole stack, and now I'm proud to announce that Rails 7.1 has HTML5 sanitizer support. Thank you. Thank you. If you're upgrading, these are the 3 configs you need to care about. It's in the documentation. One last note. There's a thing that I think is the future of sanitization that I'm going to be thinking about. There's a sanitizer API draft proposal that's currently being considered to standardize what a sanitizer API should look like to avoid confusions of parsing context. So what parsing context means is how you interpret any random string is going to depend on what that string's parent node is going to be. So here's an example. If the parent element is a div, then this little mblah string will be interpreted as markup. It'll auto-close the em tag and build the tree with a sub element. But if the parent element is a text area, then it's interpreted as a string and gets escaped. So if I'm going to sanitize em_blah, it's actually really important to know where in the document that string is going to end up. And the Rails Sanitizer API does not support this at all today. But I think it would be a really good thing. So that's going to be the future of how we evolve the Sanitizer API. But that's really all I had today. Thank you so much for listening to me ramble about security. Go forth and sanitize.